Hi everyone, I am Liam Lawson, and for my Physics 302 honors contract, I am showing you guys how to solve 3 problems. In this video, we will be evaluating this contour integral, which is the integral of cos z minus 1 over z cubed dz, where c is any contour around the origin 0. So, we see a power of z at the bottom. That makes us think we want to invoke the generalized Cauchy theorem. But to do that, we have to show that cos z minus 1 is regular. So, to start doing that, first we note that cosine of z is equal to e to the iz plus e to the negative iz over 2. Then we plug in our standard z equals x plus yi, which gives us cos z is equal to e to the negative y e to the ix plus e to the y e to the negative ix all over 2. So now we remember our pre-calculus with the cis notation. And e to the ix equals cos x plus I sine x, and similarly e to the negative ix equals cos x minus I sine x. So if we expand in terms of first cos x and then I sine x, we get e to the negative y plus e to the y I over 2 times cos x. And of course we remember to subtract 1 since that's our original function. So I'm going to write this as f of xy. F of xy is equal to this plus the I sine part is going to be I times e to the negative y minus e to the y over 2 times sine x. So now we have our u and our v, which means after a simplification to u is equal to cos x hyperbolic cosine of y minus 1, and v is equal to negative sine x hyperbolic sine of y. We can plug in our Cauchy-Riemann conditions. So du dx, x, the negative 1 goes away, the cos x becomes negative sine x. We have that, I'll erase this work up here now. We have that del u del x is equal to negative sine x hyperbolic cosine of y, and del u del y is equal to cos x hyperbolic sine of y. You don't switch negatives with the hyperbolics. Negative 1 goes away again. So cos x hyperbolic sine of y. And then dv dx is equal to negative stays, sine x stays the same, hyperbolic sine becomes hyperbolic cosine, so negative, no wait, this is cos x, this is dx, sorry. So negative cos x hyperbolic sine of y, and dv dy is negative sine x hyperbolic cosine of y. So these are equal, these are negatives of each other, and that means that cos z minus 1 is a regular function, and we can, and if we set f of z is equal to it, then we know by the generalized Cauchy theorem that we should have 2 pi, that our integral is going to be equal to 2 pi I over 3 minus 1 is 2 factorial times f double prime of 0. So f prime is negative sine z, f double prime is negative cosine z, so we get pi I times negative cosine 0, which is negative 1, and so our answer is negative pi I. Thank you for watching this video. I hope you found it informative, and be sure to check out the other 2 videos I'm doing for my honors contract. Thank you, and bye.